In this video, we are going to look at inverse functions. So we will discuss what an inverse function is and what are their essential features and how can we determine whether any function has got an inverse function or not. Okay, functions are sort of a transformation. So if the function is something like a black box kind of thing, for our purpose, we can say that this is a function. We give it an input, and we get an output. The input is normally x and output is y. Yeah, so in this respect, function is not different from any mathematical operation. You have a mathematical operation, you multiply something by some number and you get an input here, you give a number here, and you get an output here. Yeah, inverse function is just the reverse of this transformation. So in this particular case, multiplication is a function and its inverse function would be when we go in the reverse direction, when we are given this output and we get our input back. It basically undoes the transformation. Very simple, and we know that in this particular case the transformation will be a division. Yeah, so in case of a function as well, when this is a function f, we give it an input and we get an output. The inverse function would be that we give this output here and we get our input back. So whatever we'll call it input, even though it's an output here. But the whole idea is that this transformation is proceeding in the reverse direction. So we give this input, we get that output, and we give this output back and we get our input. So let's look at an example, and that will help us develop a few things about inverse functions. So let's say I have function f, which is f is equals to x plus 1. Now, very simple, what it means is that I give an input of 1 here. So let me put a box here as well. So this is my call it function. I give it something and I get my output here. Yeah, so the input that I give, this is my input, and as we discussed, this is x and this is my output, which is y. So if I give an input of 1, I get an output of 2. If I give an input of 2, I get an output of 3. When we relate this to our functions and relations, we can say that 1, 2 and 2, 3 lie on the function f. So far so good. So when we are looking at inverse function, what we are talking about is that we give a 2 and we get 1 back. So it will be like this, that this time we give it a 2 and we get 1. We give it a 3 and we get 2 back here. So that kind of thing is what we call an inverse function, and this is how we denote inverse function. So if you look at this equation, original equation f was y equals to x plus 1. So all we are doing is, when we are talking about inverse function, is what should be the value of would be the value of x when we give it a value of y equals to 2. In other words, we are trying to find x this time, not y. Yeah. So we look at this particular case here, and we want to give a 2 here. Y is 2, and we need to find the value of we give a y of 2, and we need to find the value of x. Likewise, we give the value of y equal to 3 here, and we need to find the value of x. We can do this algebraically, straightforward. So we solve it algebraically and we find that x is equals to y minus 1, and it basically serves a purpose. Yep. I mean, we can see that if I give y equal to 2 here, I get x equals to 1. And likewise, when I give y equals to 3 here, I'll get x equals to 2. So that basically could be our inverse function. But functions are not written like this. Functions are always y equals to fx. So what we do is we change the variables here, and the function that I get basically is y equals to x minus 1. All I'm saying is whatever is the value of x I give here, my y will be 1 less than that. And incidentally, we denote this as f inverse. Now looking at this, we can say that inverse function is that inverse function is that where 2, 1 and 3, 2 lie on it. So these are the 2 points lying on f inverse. So we can see here, we can see that 1, 2, 2, 3 lie on function f, but 2, 1 and 3, 2 lie on its inverse. And when we look at these two closely, we see that all we have changed is we have changed x and y. And this is a very neat feature, and we can generalize it. I'll write it like this, that if a comma b lie on fx, then b comma a will lie on f inverse x. It's a very useful and very neat feature. We'll look at it in bit detail. So let's take the case of this function we already talked about. I'll plot it here. And so your function f was y equals to x plus 1. So we will have a function looking like this. Y is equals to x plus 1 will be something like this. Yeah, and we already looked at it. There were 2 points we talked about. So this point is 1, 2, and that point is 2, 3. Okay, and the inverse function that we taught, we found that inverse function is the function which passes through these 2 points. Yeah, we just change x and y intervals. So we find here that this is 2, 1, 2, 1 will be here, and 3, 2 will be somewhere here, and we get a straight line which looks like this. Now, the thing that I want to highlight is not visible in this, so I'll take one more example and then I'll come back to it. So other example is that I got a function f, y equals to fx is equals to 2x plus 1. Yep, so the 2 points that lie on this line are, say x equals to, let me say x equals to 1, y equals to 3, and x equals to 2, and y equals to 5. So inverse function f inverse will be that function on which points 3, 1 and 5, 2 lie. Yeah, okay, so okay, I think I've stalled a bit more than I should have. Okay, so let's also mark these points. 1, 3 will be here, and 2, 5 will be there, and we will have a function looking like this. And the other function 3, this point is 1, 3, and this point is 2, 5. So we have 3, 1 here. So this here y coordinate was 3, here x coordinate is 3, and here and x coordinate was 1 here, so x coordinate goes 1 here now. And likewise x equal to, I think this point is not marked correctly, so I'll just clean it up, and this is my 2, 5. So 2, 5, so this was 2, 5, y is 5 here, so this time x is 5 here, and x is 2 here, so y will be 2 here. So that's the kind of thing I get here. So you can see that all we are doing here, we are just interchanging the x and y coordinate. And so whatever the value of x, whatever the value of y we had here becomes the value of x here, and whatever the value of x we had here becomes the value of y here. And this is nothing but reflection in the line y equals to x. This is my fx, and that is my f inverse x. The same is the case here as well. These two lines, y equals to fx and y equal to f inverse x, they are reflection in line y equals to x. And in any case, we can guess this thing, because when we are doing this, when we are changing the coordinates, all we are doing is we are making y-axis the x-axis and x-axis the y-axis. When you interchange the axis, what you get is the reflection in line y equals to x. So this is a very neat feature. I'm going to write it in words here, that reflection of fx in the line y is equal to x is f inverse x. Yeah, so basically you reflect one and you get the other one. Let's look at one more thing, that we as we discussed. I think I can scroll back up there and go back to the original the starting discussion that we had. So here, if this is my function, what is doing it, what the inverse function does that it reverses the transformation. It reverses the change that had been brought about by function f. So if you concatenate a function f and then you do the function f minus 1, you should get your original variable back. What it means is just like a multiplication division thing. You have a number, you times it with 2, then you divide by 2, you get your original number back. Yeah, your effect is undone. So same is the case with inverse functions as well. You have a value, you have a x, and you have this transformation happening. Then whatever you get there, you give it to f inverse x, and you will have your original number back. And we can check this thing. This is a very important feature of inverse function. Inverse functions, okay, let's look at the example. I think that would be better. So starting with my original starting function, f is equals to y equals to x plus 1, and then we'll look at x is equals to y minus 1. Yeah, so this was f inverse x. So now we can find f inverse x. What we have is f inverse x. F inverse x we already got. We know that it's y minus 1, so y minus 1. And when I do f of this, all I need to do is whatever value I have here, I put here, and I should get sorry, I haven't written it correctly. Sorry, this is my y is equals to x minus 1. Sorry, so this is my x minus 1, and to find fx, I just need to substitute x minus 1 in place of x here. So I get x minus 1 plus 1 is equals to x. And this is the case with all inverse functions. I think I should put that here as a note, and it works in both ways. So you get f inverse is equal to f inverse of is equals to x. That's a very important feature. Okay, one more thing we need to cover, and let's look at this function again. This is a y equals to fx. This is y, that's x. And when we are trying to find the inverse function, when we are trying to implement fx, what we have is we are given one value of x, we get this value of x, and we get this value of y. This is our input and this is our output. If you recall from previous videos, of function is one in which one value of input relates or maps to only one value of the output set, yeah, one value of the second set. And that basically can be seen here, that in this particular case we are giving one value of x here, and this function gives me just one value of y, so we know that it is a valid function. Yeah, this thing is really important. Let me again tell you that in this function, a function is a function, a relation is a function when one value of input maps to only one value of output. So this is a valid function. And when we are trying to find f inverse here, if we are trying to do the inverse here, what we do is we are given a y value and we need to find an x value. So here also we can see that I give a y value here to this to the graph. I mean, I will have another graph there. That's my f inverse. If I do the graph, but I can do the transformation here. I'm just without changing variable. I'm trying to check it. So I see that if I give one value on this axis, I get only one value on the x-axis. So again, that tells me that it's a valid function. Yeah, in the reverse direction also, one value relates to one value. One value maps to one value. Yeah. So in this particular case, I think this this graph will confuse us. So I'll just keep it here. So in the reverse direction, just to repeat that, in this particular case, one value of input here gives me one value of output, and in the reverse direction, one value of this variable gives me one value of this variable here. So it is a valid function. Now let's look at another function. I have this kind of function. So first thing, let's check whether this is a function or not. Now all functions need to pass a vertical line test, which basically just means that every value of x should relate to only one value of y, or one value of x input should relate to only one value of output. So here we can see that every vertical line crosses the function only at one point. So if I give this input, I get that output. Yeah, so one input and one output. So this is a y equals to fx is a valid function. And why? Because it passes the vertical line test. Now instead, if I am given the y here, I am given the value on y-axis now, because we are trying to look at the inverse function when we are given value here and we need to find the value of x here. So if I am given one value of y here, I find that I get two values of x here. So in the reverse direction, it's not working. In the reverse direction, I give one value of y and I am getting two values of x. What it means? It means that in the reverse direction, it is not a function. Yeah. For a function, for a relation to be function, what we need is that one value of input should give you one value of output. So we are trying to work in the reverse direction here, and we find that one value of y gives you two values of x. So we can see that it is not a valid function. Now, looking at this, I think you would be able to relate to what I'm saying here. What I'm going to state here is that for a function to have an inverse function, it should pass horizontal line test. And horizontal line test is nothing but saying that the horizontal line should cross the graph only at one point. Yeah. So if you have a graph and that graph passes vertical line test, then it's a function. And if it also passes horizontal line horizontal line test, then it will have an inverse function as well. And that's where we'll stop.